Hi, today I'm going to show you how I run a sun sight down using just the Almanac and Norries. Some people are a little bit wary of doing this because they think it's complicated. It isn't complicated, it's just basic adding and subtracting. It's very easy, that's why I do it. Okay? Okay, for the purposes of this demonstration, I'm assuming that you've got a DR, you've run it down from a plain sailing or something in the morning, you're familiar with your sextant and its errors and what to do with it. We will be running through it, this is more about the calculation. Right, I'm not going to go into the theory in this because we haven't got long enough to do it. All I'm going to do is show you how I run it down. Okay, so it's just the practical side of running down this side. Okay, what I'm doing now is I've brought the sun down to the horizon. I'm just kissing the horizon, carving an arc across it. It's best to swivel from your hips for some reason, but I can make it there. I'm quite happy with that now. So I'm going to go back in when I'm totally happy. And now. Okay, so I took my sight. How you get your time is up to you. If there's two of you, you can have someone with a watch and just tell them when you're happy and they can log the time. If there's one of you, you can count elephants or 1,000 or 1,000, 2,000, 1,000 Mississippi. Get back to the chart table, get your time, get it noted down. Then you've got to read off your sextant reading. Okay, so you can see from that I've got a reading 41 degrees 35.8. Okay, we've got what we want from our sextant now, so we'll put it away safely in its box before we do anything else. Always look after your gun. Good idea to have get yourself a sight book, little A5 or A4 pad, or whatever, so to keep all your records in. Also to book a memoir when you come to do it. If you haven't done it for a long time, you can look back and see what you did. So I've got my sight book. We're going to start running down the sight. Okay, we've got the information we need now. We've got our date, we've got our time UTC. That just means I've done the sun, and obviously we've got our DR, which is very important for going into the tables with. So now we can start putting the figures on the paper. Okay, we can see we've got our sextant altitude, or height of sextant, HS. I indicates index error. On this particular sextant there's 0, but our dip, so our height of I, is minus 6.7, which leaves us with a height of 4129.1. Okay, yeah, from the Almanac, from the dip chart, we can see our bridge on this one is 14.5. So between these two figures, which means the dip error is minus 6.7. Okay, now from the Almanac again, we need to apply the correction. Okay, in this case it's plus 15.2. Okay, we're back to the altitude correction table again. Obviously we're between October and March because we're in November, and we're using the lower limb. If we run down the table at the side, we can see that our H, 4129.1, lies between 4106 and 4356, which gives us a correction of plus 15.2. Okay, so we apply that correction, plus 15.2 gives us an observed height, HO, 4144.3. Okay, now we've basically got to take the difference between this figure and 90 degrees because we want the angle from our zenith to the height of the sextant. So all you do is minus that figure from 90 degrees. Okay, now I've done that little calculation. You can either use a calculator or just do it longhand, but always have a bit of scrap paper by. Okay, and so we've got a true zenith distance, 48 degrees, 15.7. Obviously we'll need that when we get our calculated zenith distance. That will give us our intercept. And the next thing to put in there is your DR lat, which you've got from the top of the page, down here. See that? Just fill that in here, 1942.0. Okay, so now we're going to run down our GHA to find our LHA, and for that we're going to go into the Almanac. Okay, you can see we've gone into the daily page now of the Almanac. Okay, 12th, 13th and 14th of November. We're going to go down here, in this column here you can just see the sun. It says the sun, that's the column we're going to use for getting our GHA and end up with our LHA. You can see our time now. Okay, that was our time. Okay, 0700 in the Almanac. You can see that our GHA is 288.54.0, and the declination you can see is south 18 12.8. Okay, so I've got written that down, GHA 288 degrees 54. Okay, declination is south 18 12.8, and there is a D correction we have to apply. In this case the D correction is a little plus 0.7. Where we get the D correction for is at the bottom of the page. You'll look down, you'll see a small d under that column with the sun, and it's 0.7. That is not the correction. That's what you're going to go into the increments for to get your proper correction. Now if you look up here, you'll see that it's 12.8 rising to 13.5. That means that the D correction is always added. If it's decreasing, you subtract it. If it's rising, you add it. Okay, we've come to the back of the book now, the buff coloured pages. For our seconds, minutes and seconds, we've got 59.58. So I've come to 59 minutes, and then we come down the page to 58 seconds. Okay, we can see now that we've got 59 minutes, 58 seconds. We have an additional 14 degrees, 59.5 to add on. In addition, on the right hand side of that page you'll see the VD corrections. We're having a D correction. Go down until you find your 0.7, and in this case it is actually a plus 0.7. Okay, so you can see now we've got our GHA, we've put our increments in, we've added that on to give us our true GHA. Okay, and over in this column we had our declination, which we got from the daily pages. We had the D correction, which turned out to be plus 0.7, which we've added, which gives us a true declination of south 13.5. Okay, what we've got to do add in now to get our local hour angle. Obviously we put in our longitude DR, which we know is 086 34.5. okay, that's always added. We're east, so it's always added. If it was west, it's a minus. I always put a notation in the margin just to remind me, because it'd be a silly mistake otherwise. So we're going to add those up. Okay, we've added in our DR longitude, which has given us an LHA of 389.28. Okay, obviously we need to deal in a figure less than 360, so we take 360 away from that, which gives us 29.28. LHA of 29 degrees 28 minutes. Okay, so we're finished with this now. We're finished with the almanac. We're going to move on to Norries, finish off the site. We'll finish it off with that, so we're finished with that. Throw that away, keep this. Okay, next thing we want to do is we need to work out our azimuth. For that we're going to use Norries ABC tables. In this edition of the Norries, they're in the 300 pages. So at the top, table A, table B. Okay, so we've entered the tables. You enter the table with your local hour angle at the top, okay, and your latitude DR down the side. Okay, so we've come into the table, we're looking for 29.28. There's 29.20, 29.40, so it's somewhere in the middle of those two. We can now come down the table. Our approximate DR latitude is around about 20 degrees. There's an element of interpolation to do. Okay, so I've come into the tables now. We've got approximate latitude of 20, and we've got our LHA of 29.28, which is down this column here in the middle. And you can see that the figures are 065, 064. Okay, above it is 061, 060. So an easy bit of mental interpolation tells you that the figure you're looking for is about 062. 062. If you can see that, 646360. One of the things I love about Norries is it tells you what to do in a lot of cases, and this one tells you that the A correction is named opposite to latitude except where the LHA is between 90 and 270. Well, our LHA is 29.28, so it's going to be opposite to latitude. Our latitude is north, so A is named south. Okay, you come across the page to the B table, okay, and you're entering again your local hour angle at the top, but this time you're using declination of the body at the side. Okay, so we're coming down to 18, which was our declination approximately, okay, and we're going across again to our 29, 20, 40 column. We can see there that the B figure is 0.66.66. Okay, there's no interpolation required, so we're going to use 0.66.
Again, Norries is your friendly hardback. At the bottom of the page it tells you local hour angle, always named the same as declination. So your B correction, it's always named same as declination. Okay, our declination was south, so B is named south. Okay, this is our A, this is our B, they're both south. If they're named the same, you add them together. If they are a different name, C correction takes the name of the higher figure. Okay, so we can see that our C figure is going to be 1.28, so we need to go to the C table, hence the ABC table. Okay, so we're in the C table. All we've got to do is go along the top, look for our figure of 1.28. There she blows, 1.28. Come down the side for our approximate latitude, and in the C table it is very approximate. Okay, so I've come across, I found our figure, 1.28. I come down to our approximate latitude, 20 degrees. Okay, and we get a figure of 39.7. Once again, at the bottom of the page, it's a nice explanation. If A and B have the same name, C equals A plus B, and C takes the name of A and B. If A and B have different names, C equals A difference B, and C takes the name of A or B, whichever is the larger, which I said before. The azimuth is north or south, depending on the name of C, and E, or west, depending on the value of LHA. Then it tells you what to do. It is east if the LHA is between 180 and 360, and it is west if the LHA is between 0 and 180. Our LHA is 29 degrees 28, so we know that the azimuth is south 39.7 west. Okay, so we've got finished up with an azimuth of south 39.7 west, which equals 180 plus 39.7, so your azimuth in degrees is 219.7. Okay, so just before we move on to Norries tables again, this is what we're going to write down initially. We're going to look for a log haversine of your LHA, so you're going to be entering the tables with your LHA. Okay, the log cosine of your latitude, so you're going to be entering it with your latitude, and the log cosine of your declination. We've got all these figures, so we can just go to the tables and find out.
Okay, now we're going to move into the haversines. This is what some people say is a bit too complicated. It's not complicated at all. We just need to add up fairly small figures. Okay, so we move into those now. We're nearly finished. Okay, we're coming into the haversines page of Norries tables now. Okay, we've finished with the ABC tables. We're in the haversines page. In this particular edition, they're on the 260 pages. Okay, somewhere in the middle. If we look at the top of the table for 29, you can see on this side is the log haversines, and on this side is the natural haversines. Quite easy, it says haversine at the top. You need to enter those pages with your LHA at the top, okay, your minutes of LHA down the side, and you'll be taking a figure from here and writing it down. Okay, so I've come into the tables, okay, with our LHA of 29 degrees. And at the side of the table, our minutes of LHA, which is 28 minutes. 29, 28. Okay, left-hand side of the table, we've come down, 29, 28, and the figure we get is 8.81076. We write that down. Okay, now we need to find the cosine, log cosine of lat. Okay, our latitude. So you enter the tables, in your cosine tables. Okay, you can see here sine, cosecant, tangent, cotangent, secant, and cosine. We're looking for the cosine. We're going in with our latitude, which is 19 degrees 42.0 east. So we're on the 19 page. We come down the column to 42. Okay, we've come down 19, 42.0. We need to come across because we want the cosine. We just come across the page, we look at the figure, and the figure is 9.97381. We write that down. Okay, so that other one we needed to be said was log cosine of the declination. So we enter the cosine tables with 18, and we're working our way down to 13.5. So we come down 18, 13. Okay, so we've come down 18, 13. We need the cosine, so we're going to go along here.
Okay, and the figure we have is 9.97767. However, it was 13.5. If you look in the middle, you have all your decimal points. If you look at 0.5, it tells you that you have to minus 2 from your figure. It's always a subtraction. So our figure was 97767 minus 2 makes it 97765. So our actual figure to write down is 9.97765. Okay, so we've now got our log haversine LHA, our log cost lat and our log cost dec. All we have to do is add them up. So I've added them up. You can use a calculator or do it just in your head, it's up to you. And I've come up with a log haversine 28.76222. Okay, the final part we've got to do now, we've got to find the natural haversine of this log haversine. We need to find the natural haversine of the D plus or minus L, which is your latitude declination. Now this is the bit that some people find tricky, but it does get very, very easy with practice. We need to go back into our haversine tables in Norries, and we're looking for a figure in the log haversine column of 8.76222, or the closest we can. Then it will become apparent why we need to do that. Okay, so I've come into the haversine pages again of Norries. Okay, and I found a figure that is very, very close, 76227. Now the natural haversine, which is what we're after, is 0.05785. In this instance, it's close enough that I will take that figure. If there was a big difference, I may have to interpolate, but obviously you can interpolate quite easily on a calculator. So in this instance, I've found a figure, the natural haversine of the log haversine, 0.05785, and it's just a matter of getting used to looking through the tables. If you scroll up, you'll see the figures change, 8.7742. You just get used to doing it. That's all you have to do. Once you get the hang of it, it's very, very simple. Okay, the next figure we need is the natural haversine of D plus or minus L. Okay, the D plus or minus L figure is obtained from your latitude and your declination. If they are the same name, north and north or south and south, you subtract the smaller from the larger. If they're different names, as they are in this case, north and south, you add them together. So our difference D plus or minus L is 37 degrees 55.5. That's what we're going to the tables with. So it's back into the haversines and we're looking for the 37 55.5. Okay, we've got 55 again. We're going to come along to 37. This is 35, 36, 37. Okay, we're looking for a natural haversine, which are in the right hand column, as we know. And we've got a 0.5 correction. Okay, because our difference is 37 55.5. If you look at 0.5, just so happens it's adjacent, it's a minus 4. So the figure we're looking for is 10551. Now all we've got to do to obtain the natural haversine of the calculated zenith distance is add these two together. Okay, so we know that the natural haversine of the calculated zenith distance is 0.16336. So what we've got to do is look in the natural haversine column to find this figure, 0.16336. Now, if our calculations are fairly good, it should be in the region of our true zenith distance, 4815.7. So we need to go to the Norries tables haversine section again and look under 4815.7. We've got 47 degrees 40 minutes. If we come back to the 16328, in order to make that up to 1636, we need to plus 8. If we come down to 8 here, we can see that the decimal point is 0.7. So our calculated zenith distance is 47 degrees, which we got from the top of the page, 40 minutes, which we got from the side of the page, down the side, decimal 7. That is our calculated zenith distance, which we add into the book. Okay, we've got our calculated zenith distance now here, 4740.7. We move our true zenith distance across from our other column, here, true zenith distance, 4815.7, into that one. We subtract the smaller from the larger, which gives us a 35 nautical mile intercept. The reason for this large intercept is that I deliberately chose a DR position well away from where I actually thought we were, so that we could get an intercept. The thing to remember is true, tiny, towards. True, tiny, towards. If your true zenith distance is smaller than your calculated, then your intercept is towards. If it isn't, your intercept is away. Okay, so we can just finish off now to illustrate that. That's our DR. There we have an intercept of 219.7 towards, going this way, and an intercept distance of 35 towards, 35 miles. I've used a little scale up the top here to measure that. You could do this graphically on the chart, or you could use a sailing. But on this sort of distance you could do whatever you like, it doesn't really matter. But that's what you've got graphically. You could put that's your DR on the chart, 35 nautical miles towards your intercept, 219.7. Draw a line at 90 degrees. That's quite simple to do, using one of these little chappies like that. Draw your line across. That's your position line. You're somewhere on that line when you took that sight. Okay, so that's the end of my example. I hope you understood it. Okay, Norries is really good. You only need to carry Norries and an almanac around. Don't forget your sight book, pair of dividers. These little math sets are awesome for plotting on bits of paper and everything else. And of course, scientific calculator helps if your brain's a bit tired. Hope you understood it. Thanks for watching.